This is example 11.2 from Discovering Design with Chemistry. What is the chemical equation for the reaction between H2SO4 and NH3? Now, thankfully, that means that we know that these are going to be the thing having the reaction, so we can go ahead and write them on the reactant side, and then we can figure out what to do with them on the product side. All right, if you look at these two chemical formulas, one of them starts with an H. That immediately should tell us that this one is our acid. Oh, why did I put a E on the end? And this is our base. So this one is going to lose an H plus. Now it has two of them, and so it's going to actually lose two H pluses. And those are going to go to our base. But the problem is the base cannot take but one of those. So we're going to need more than one of those to accept the hydrogen. So we're going to go ahead and put a 2 right here, because if we have two of them, then we can have NH4 from the first one. We have NH3 and NH3. These can become NH4. These can become NH4. So we're going to have two NH4. And because this H plus is going to each of them, they're both going to have a +2 charge. Now when this H plus goes away from each of those, what we're left with is the SO4. Now if you take this and you split it into this, because this had a 2 down here, it must have come from having some number here. And you can imagine this one having a 1 down here, which means this came up here. We know that this one's a plus, so this one must be the minus. So that just kind of helps you figure out what the charges need to be. You may have it memorized because this is one of your polyatomic ions, but in case you don't, you can see where it came from, because you can see what this used to be by splitting it into its two pieces and then taking the number right here. And we know this is a set, so the 4 isn't the number. There's a 1 imaginary right here, and we take those two and we can move them back up here into their plus and minus charges that they used to have, so we can figure it out. So the leftover piece on the product side that we haven't used is the SO4, and that's going to have a 2 minus charge. The only thing we haven't added yet is that this is all happening in like an aqueous solution, so we need to leave that over there. That's why these ions are able to split up and then reconnect with other things. All right, so we can just check and make sure that we've got everything lined up right. We have the same number on both sides. So, oh, that was supposed to be an eraser. All right, this one is done, but we should always check. We have 2 plus 6 hydrogen over here, and we have 8 over here. I counted wrong over here somewhere. Yes, 2 plus 6 makes 8, and we have 8. Not really sure what I was counting just now. We have 1 S here and 1 S here. We have 4 oxygen here, and we have 4 oxygen here. We have 2 N's here and 2 N's here, and then we already counted the hydrogen, which I counted wrong the first time, but 2 plus 6 makes 8, and we have 8. So this is balanced, and this is finished, and that's the answer to the question.